Hello guys, this video is about increasing and decreasing functions. So in this video I'll explain how to find increasing decreasing intervals in a function and the relation between the negative slope with decreasing functions and positive slope with increasing functions and so on. So let's take a look at the first set of information. A function is increasing if on an interval if x1 is less than x2 and f of x1 is less than f of x2. So we can say that we have a same relation between the values of x's and values of the functions at the same values, at those x values. So we have the same relation. There's less than here, less than here. Let me show you what I mean. Let's suppose we have a graph. Let's suppose this is a coordinate plane and this is an increasing function. So on this increasing function, let's find 2 points. Let's talk about 2 points. Let's say this is the first point, x1. This is the second point, x2. And we know that since x1 is less than, on the left side of x2, x1 is less than x2. What about the relation between the functions at those two values? So the value of the function at x1 is here, f of x1. The value of the function at x2 is here, f of x2. So x1 is less than x2. At the same time, f of x1 is also less than f of x2. F of x1 is lower than f of x2. So this is less than f of x2. So we have the same relation since the function is increasing. See, x1 is less than x2. F of x1 is also less than f of x2. We have the same relation. On the other hand, if we have a decreasing function, we totally have an opposite relation. Opposite relation. What do I mean by that? If if x1 is less than x2, then f of x1 is more than f of x2. Let me show you what I mean on the graph. Let's suppose you have this graph. Let me erase the previous one. Okay, let's suppose this is coordinate plane and this is the decreasing function. So on this function, let's use 2 points. Let's say this is x1, this is x2. x1 is less than x2, right? This is left side of x2, so this is less than x2. What about the values of these functions at these two x values? For x1, this is a f of x1. For x2, the y value of x2 is here, f of x2. x1 is less than x2, but f of x1 is more than f of x2. So we have totally the opposite relation. x1 is less than x2, but f of x1 is more than f of x2. This is higher. This is one more. So this information is important. There will be, we will solve a question about this information. So let's take a look at the question after we talk about the relation between slope and increasing and decreasing functions. We will be using this information, keep in mind. So a function is increasing from left to right if it is rising, decreasing from left to right if it is falling down, and constant from left to right if there is no movement. If it stops, if the function stops, it's constant. You already know these kind of things. So let's identify the increasing and decreasing intervals. For this graph, what is the increasing interval? So from left to right, this graph is increasing until this point. So this part is increasing part. What else? We have one more part increasing from this point to the right. It's also increasing. So when I write the increasing interval, I have two parts, so I'm going to combine them by using union. So increasing interval will be from negative infinity, since the graph extends from this way, to what number? Negative 2. It goes up to negative 2. So when we write the interval, we never include the numbers because that numbers are neither increasing nor decreasing. The function here is constant, so we don't include these turning points. So negative infinity to negative 2. Union, the second part, starts with 2. At 2, similarly, function is constant, neither increasing nor decreasing, so we don't include this number. So 2 to positive infinity exclusive. This is the increasing interval. What about decreasing interval? So between those two numbers, function is falling down from left to right, right? It's decreasing. So what is the decreasing interval then? Decreasing interval from negative 2 to 2. So like the other part, we are not including the numbers. So between negative 2 to 2, function is falling down, decreasing. So this is how you identify increasing and decreasing intervals. Okay, let's take a look at the ministry question. 2023 second attempt. In which interval f is decreasing? So we are looking for the interval that function is falling down from left to right. This part is increasing. That part is also increasing. This part is decreasing. So this part. So how do you write the interval? This starts from this point, which is 1, and at this point, 3. So it's between 1 and 3 inclusive. All right. Okay, starts with 1, ends with 3. Between those two, it is decreasing. Okay, this is the first type of questions that you may face about this topic. Second set of informations. This graph is pretty important. This gives you the information about the relation between the slopes and the functions. So if a function is decreasing, then what can we say about the slope? If it is decreasing, then when you put tangent lines to any point on a decreasing function, it is negative. Slope is negative, right? Put tangent lines to any point that you want, the slope is negative. Remember, slope is negative if it is falling down from left to right, positive if it is rising from left to right, and 0 if it is horizontal line, if it is constant. So by using this information, since slope is negative, slope is about derivative, so we can say f prime is less than 0 when function is decreasing. And same idea, if a graph is constant like that, there is no slope, horizontal line. What is slope of horizontal line? It is 0. Since slope is 0, slope means derivative, so f prime of x is also 0 when it is constant. What about increasing function? When it is increasing, you put tangent line to any point that you want, it will always be positive. So slope of an increasing function at any point is positive. Slope means derivative, so we can say derivative is positive. So this is just about that idea. Slope is negative, meaning derivative is less than 0. Slope is 0, derivative is 0. Slope is positive, then derivative is positive. So this set of information is pretty important. We will be solving questions by using this information generally. Okay, I generally make a table like that to illustrate it in our mind. We can picture it in your mind, and you'll solve questions easily. When f prime is positive, function is increasing. When f prime is negative, function is decreasing. So in the following videos, I will be making this table to figure out increasing and decreasing value intervals. Okay, one last question and I finish the video. Assume that f prime is negative in this given interval. Which of the following is true? When you look at the options give you the relation between the values of the function at 2 and 6. This is equal here, this is less than this, more than this, and stuff. So we already talked about this relation in the beginning of the lesson. the first part, if you remember. If x1 is less than x2, f of x1 is less than f of x2, meaning the function is increasing. X1, but if it is the opposite, relation is the opposite, then function is decreasing. So what kind of function we have here? So we are going to combine this information with that information. So both of them will be useful to solve this question. So in this question, we are said that f prime is negative. If f prime is negative, what can we say about the function? Is function increasing or is function decreasing? If f prime is negative. If f prime is negative, our function is decreasing. So if our function is decreasing, what is the relation between the values of the x's and the values of the functions? So we can say x1 is less than x2, then f of x1 is more than f of x2. We have an opposite relation. So we are comparing f of 2 and f of 6 here. Since 2 is less than 6, then f of 2 must be more than f of 6 to have a decreasing function, which gives you option B. Okay, see? So this is the combination of two different information. So in the following videos, I will be solving questions about how to find increasing and decreasing intervals from the functions algebraically.